Alright, so this unit we're going to be primarily dealing with, we're transitioning from the triangular trig from the right triangle into the unit circle trig, and we'll talk a little bit more about what that actually means here in just a second. But this is by far the most important part of the trig stuff that you're going to see. Alright, here we have a unit circle. And a unit circle is a circle that has a single unit, whatever measurement you're using, as the radius. And it is centered at the origin. It is of the equation x squared plus y squared equals 1. And here we have an angle measuring t radians. And of course there is our arc length that we talked about in the last unit of s. Now the word trigonometry means measurement of triangles. Trigonometric functions with domains consisting of sets of angles were first defined using right triangles. By contrast, problems in calculus are solved using functions whose domains are sets of real numbers. That means we can have any number. Therefore, we introduced the trigonometric functions using unit circles and radians rather than right triangles and degrees. Now, you don't have to write all this stuff down. The big thing is understand where trigonometry comes from. It did come from the measurement of triangles and the study of triangles. But when we got into more complex things that we're dealing with, things other than just triangles, we understood that we needed angles that were going to be greater than 180. And when we got into that, that's where the unit circle comes in. When we're stuck with a triangle, remember all three angles of a triangle have to add up to give you 180 degrees. But we're not always limited by an angle that's going to be within 0 to, let's say, 188. Let's say the other two angles of that triangle were 1 degree each. The largest angle we could deal with would be 188 degrees. Well, there are angles that are much larger than that. So we have to deal with those using unit circles instead of triangles. Now, as I mentioned, this you definitely want to have written down somewhere. A unit circle is a circle of radius 1 with its center at the origin of a rectangular coordinate system. And the equation of this circle is x squared plus y squared equals 1. Figure 419, that was the picture we just looked at, shows 1. Now, as we learned in the last section, the arc length s in that picture can be found by r, the radius, times theta, the angle in radian measure. Well, if the radius is 1, in this case the arc length is exactly the same thing as the radian measure of the angle intercepted. So this is what it comes into. This is what it boils down to. In a unit circle, the radian measure of the central angle is equal to the length of the intercepted arc. Now, with these, we can have both positive and negative angles. In this case, we go in this direction and our angle T is positive. Now, guys, you need to understand, regardless of which way the angle goes, the arc length is always going to be positive. It's literally a length like you would measure along a road or along the side of a desk or something like that. There is no negative measurement on length. So your arc measure will always be positive, but your angle measure can be positive if it goes counterclockwise from standard position, or it can be negative if it goes clockwise from standard position. And if you don't remember what standard position means that its vertex is at the origin and its initial side is along the positive x-axis. And that's what we measure from. Now, we begin our study of trigonometry in the unit circle by defining the 6 trigonometric functions. The inputs of these functions are real numbers represented by t. That'll be the angle. You'll also see it as theta, so don't get messed up if you start seeing theta and t interchangeable. They're just representing the angle we're talking about. And the outputs involve the point P, which is the coordinate pair xy on the unit circle that corresponds to t and the coordinates of this point. This P right here is going to be these parts. Just the point on the unit circle at the end of the terminal side. That's all it is. So don't get too confused. It's just the xy coordinate plane point at the end of that terminal side. Now, the trigonometric functions have names that are words rather than single letters, such as f, g, and h. For example, the sine of t is the y-coordinate of point P on the unit circle. So sine t equals y. So the sine of some angle is nothing more than the y-coordinate on the unit circle at the end of that terminal side. Now, the value of y depends on the real number t, the angle, and thus is a function of that angle. The expression sine t really means sine with parentheses around the t, where sine is the name of the function and t, a real number, is an input or the domain of that function. Alright, now here are the names of the 6 trigonometric functions. By the way, they're the exact same names of all those trig functions we already know. And their abbreviations. We've already seen all this. This is nothing new. And then here at the bottom, in the blue box, we have the definitions of the trig functions in terms of a unit circle. These you need to make sure you copy down. Now, their definition is still exactly the same. You'll notice here, sine t is equal to y, which we just learned, and cosecant t is just the reciprocal of sine. In other words, if sine t is y, cosecant t is 1 over y as long as y does not equal 0. Remember those relationships, those reciprocal identities, the sine t and the cosecant t, cosine t and secant t, tangent t and cotangent t. So those are all the exact same relationships that we learned before, but now we're defining them with those x and y coordinates. And you do need to know these. Alright, so if t is a real number equal to the length of the intercepted arc in an angle that measures t radians, and our point at the end of that terminal side is the point -1/2 square root of 3 over 2, use the figure to find the values of the trigonometric functions at t. And we want to find all of them. Alright, so we've got sine of t is going to equal the y value, so the square root of 3 over 2. Our cosine t is going to equal our x value, which is -1/2. And our tangent t is equal to the sine over the cosine, or as remember in that last thing you wrote down, y over x. So that's going to be the square root of 3 over 2 divided by negative 1/2. Now, of course, with that, we're going to have a negative, but let's go ahead and do the division. Remember, division, you're going to change the operation, flip the bottom one, so we're going to end up multiplying by negative 2 over 1. Well, the 2's are going to cancel out, so we're going to end up with negative square root of 3. All right, and what about cosecant? Well, cosecant t is the reciprocal of this, so it's 2 over the square root of 3, which will have to rationalize that denominator. And we end up with 2 square roots of 3 over 3. Our secant t is the reciprocal of cosine t, so that's just going to be negative 2. And our cotangent t is the reciprocal of this thing right here, so it's negative 1/2 divided by the square root of 3 over 2. And when we do that, we end up with negative 1/2 times the reciprocal of that, which is 2 over the square roots of 3. Once again, the 2's do cancel out, and we're left, let me block this off, with negative 1 over the square root of 3. Well, when we rationalize and multiply by square root of 3 over the square root of 3, we're going to get negative square roots of 3 over 3. So that's all you have to do. It's all based on the exact same thing. Once you get the sine and your cosine, and you can find your tangent, then everything else is based off of that. We just have a little bit of algebra to go in and work with that to get our denominators rationalized if we have square roots down there. Alright, so you guys try this one. It's, well, not very much different from the last one there. But find all 6 trigonometric functions and see what you come up with. I'm going to pause the video and I'll work it out over here, and then I'll show you what the answer is so you can check yours. So you want to pause the video in 3, 2, 1. Alright, so here are the answers. Sine t is 1/2, cosine t is the x value, square root of 3 over 2. Tangent t is the sine over the cosine, which when rationalized you get the square root of 3 over 3. Cosecant, reciprocal of that, which is 1/2. Secant t is the reciprocal of cosine, so when you rationalize it, you get 2 square roots of 3 over 3. And then cotangent t is the square root of 3. Now you may show more work here, but here's a little trick. Watch this. We know we're going to flip this thing over, the tangent over anyway, right? So when we get to right here, before we do any other work, if we flip that thing over, we don't have to worry about rationalizing it down here. We did have to rationalize it up here, but we don't have to when we flip it over down here. So one of these two is going to have to be rationalized, the other one's not. So if you keep track of your work along the way, you only have to rationalize one time. Now, you'll also notice that this is a very different angle, but what do we notice about all these trig functions? They are very much the same numbers, just with different functions. So we have a set number of values. Actually, no, scratch that. We'll talk about that when we talk about actual angle degrees. So, yeah, forget that. Alright, so here we actually have an angle given, pi over 2, and we know that that's 90 degrees, which is going to be right perfectly along the y-axis, initial side along the positive x-axis, terminal side along the positive y-axis, and the point there is going to be 0, 1. Now we know that because we're going straight on the y-axis 1 unit, and we're not going side to side, so that means x is 0 and your y is 1. So when we set this up, nothing changes. sine of pi over 2 is still just going to be your y value. Well, our y value here is 1. And your cosine of pi over 2 is going to be just your x value, which is 0. And your tangent is still going to be sine over cosine. Well, there's where we run into our problem, and this is where we had those limitations where your x value or your y value could not equal 0, because then you end up with an undefined situation. So the tangent value for pi over 2 is undefined. Now when we do the cosecant, well, if we take this and think about it as a fraction 1 over 1 and flip it over, we still get 1. When we take the cosine and flip it over to find secant pi over 2, we think about that as a fraction and flip it over, and we're going to get 1 over 0, which also is undefined. Now, the cotangent, this is where we actually have to go back to our definitions, and we'll talk more about the definitions a little later. But remember, if the tangent is sine over cosine, and we flip it over, then the cotangent is cosine 0 over sine 1, so we actually end up with 0. It's actually defined, not undefined like the tangent. So just because one of our functions is undefined, it typically means that the reciprocal, the flipped over one, is going to be defined as 0. Alright, so here's another one. I'm going to let you guys work it. I'm going to pause, but I want you guys to try this and then come back and I'll show you the work. Alright, I'm going to show you the work, or the answers for you to check in 3, 2, 1. Alright, so here are the answers for them. Check your work. The sine is your y value, so it's 0. Cosine is your x value, it's -1. And then sine over cosine gives you your tangent, which is 0 over -1, which is 0. Cosecant, the reciprocal of sine. So if we think about that as a fraction, we get 0 over 1, so when we flip it over, we get 1 over 0, which is undefined. With the secant, we're doing the reciprocal of cosine, so if we think about it as -1 over 1, when we flip it over, we get 1 over -1, which is -1. And the cotangent, when we flip our tangent setup over, we get -1 over 0, which is also undefined. I apologize for that pop-up there. I don't know what in the world my computer's doing there. Alright, so the domain and range of sine and cosine functions. Domain, remember, is your input value. We typically refer to that as your x, but in this case, remember, our t is our input. It's the angle. So we have to keep that in mind. Domain is not always going to be the x value. There are times when it's going to be some other variable or some other value that we're putting into a function and then getting values out. In this case, our input value, our domain, is going to be t. Our range we typically think of as y, but we can't think of it as just the y this time, because for the sine value, our output is y, but for our cosine value, our output is the x. So remember, all you're doing with a function is you're putting something in and getting a value out. Well, the value you put in is your domain. The value you get out is your range. Don't think of domain and range specifically in x and y terms. So let's look at those just in the cosine and sine functions. So when we're looking at sine, we can put in any value of t. So t is all real numbers for the sine function. So that's the domain. Any number we want to. And when we look at our output value, we're looking at the y. And when we look at our possible y values here, it has a maximum value at pi over 2 of positive 1. And it has a minimum value when we keep going around of negative 1 when we get to 3 pi over 2. And then it goes back to 0 and goes back up here and then goes back around and around and around. But the largest y value that we can have is 1, and the smallest y value, sine value, we can have is negative 1. So for this one, for the sine function, our domain is all real numbers, and our range is from negative 1 to positive 1. Those are the minimum and maximum values we can have coming out of a sine function. Now when we look at the cosine, it's very similar, but notice we're measuring side to side for our range values. Once again, our angle t can be anything. We can go around this circle an infinite amount of times to our terminal side, but the maximum value we can have for our cosine value, known as our x value on the unit circle, it's 1. Its minimum value, the smallest x value we have on the unit circle, is negative 1. So once again, our domain for cosine is all real numbers. We can put in any angle we want. And our range is going to go from the smallest value of negative 1 to the largest value of positive 1. So the domain of the sine function and the cosine function is negative infinity to positive infinity. In other words, all real numbers. And the range of these functions is negative 1 to positive 1, and we put brackets around it because we actually include those values of negative 1 and positive 1. This is interval notation. So remember, the brackets mean we include those values, the parentheses means we don't. And that's actually what this means here if you read the rest of this. The set of all real numbers from negative 1 to 1 inclusive. The inclusive part means we include negative 1 and positive 1. Alright, so let's find the exact values of the trigonometric functions at t equals pi over 4. Now we've already talked about this a little bit. We talked about it as the x value and the y value part on a right triangle that had a 45-degree angle. You'll remember that pi over 4 and 45 are the same. That's not a 45-degree angle. That's not a very good one either. Alright, so if this is 45 degrees, also known as pi over 4, what do we know about this side right here and this side right here? Well, remember, those are our two sides that are the same. And remember, this one over here was s times the square root of 2. Well, we can actually solve for s because we know that s times the square root of 2 equals 1. And the way we know that is if we dropped a line right here, we now have that 45, 45, 90 triangle. So this is s, and this is s root 2. Well, we know that this is a unit circle, and by the unit circle we know that this has a radius of 1, so our s times the square root of 2 side equals 1. So to find what s is, we're just going to divide both sides by the square root of 2. So s equals 1 over the square root of 2. That's a pretty weak 2. And then we rationalize by multiplying by the square root of 2 over the square root of 2. And we're going to get the square root of 2 over the square root of 4, which is 2. So that's what S is. So that means that this side right here is the square root of 2 over 2, and this side over here is the square root of 2 over 2. Well, what do those coincide with here in our triangle? Well, if you remember, this side right here is this side, and that's nothing more than what? That's nothing more than the x part of this triangle, and this part is our y part of the triangle. So now, once we know this is x is the square root of 2 over 2, and that y is the square root of 2 over 2, we can do all of our trig functions. So the sine of pi over 4 is going to equal the square root of 2 over 2. The cosine of pi over 4 is also going to equal the square root of 2 over 2. Now the tangent of pi over 4, remember, it's nothing more than the sine value of the cosine value. So we end up with the square root of 2 over 2 over the square root of 2 over 2. And what happens when you have anything over itself? Well, it's 1. All right, when we do our cosecant of pi over 4, we're just going to flip this thing over, and remember, with our work here, we can actually go back to here. We're going to get the same thing if we flip this thing over, because this and that are equal. So we end up with the square root of 2. Now I'm going to show you square root of 2 over 2, and when we rationalize that, oops, sorry, we need to flip it over, don't we? So we end up with 2 over the square root of 2. When we rationalize and multiply by the square root of 2 over 2, square root of 2 over the square root of 2, we're going to end up with 2 square roots of 2 over the square root of 2 times the square root of 2, which is the square root of 4, which of course is 2. And then these 2's are going to cancel out, so we're left with just the square root of 2. Now, once we've done the cosecant, guess what? The reciprocal of cosine, since it's the same value, is the same thing. So the secant of pi over 4 is also the square root of 2. And the cotangent of pi over 4, well, 1 is 1 whether it's upright or flipped over, so that's going to be 1. So there are all our values. Okay, we've already found all those. We're not going to do those again. Alright, so here is a list of the trigonometric functions at pi over 4. If you want to commit them to memory, you can. These are the only ones you really, well, actually these first 3 are the only ones that you really need to know. The others you can easily figure out what they are. So these are always going to be the ones that we want to know. And then we can figure these out if we have to. They're not going to be used near as much as these are. Now, let's talk about even and odd trigonometric functions. All right, the cosine and secant functions are even. Now, guys, this is the exact same definition of even and odd that we've always had with functions in general. Maybe you don't remember it, but I'm going to refresh your memory here. For an even function, f of x, if we plug in a negative x, we're going to get the exact same function we started off with. Throwing in a negative value of an x is going to give us the exact same value we would if we just plugged in an x. That's an even function. Now an odd function is very different. If we have an odd function f of x and we plug in a negative x value, it's going to change the value we started off with to make it a negative. So we can still calculate just plain old f of x, but we're going to have to throw a negative in front of it if we know it's an odd function. So for any given f of x, any given function, if we plug in a negative value and we get the exact same function we started off with, or function value that we started off with, it's an even function. And for an odd function, if we plug in a negative value of x and we get the negative of what we would have gotten if we plug in a positive x, then it's an odd function. If it's any other combination, it's neither. These are very specific about what has to happen with them. Now, taking that into our trig functions, the cosine and secant functions are even. So if we plug in a negative t, we're going to get exactly the same value as if we had plugged in just plain old t. Secant is even because it is based only on cosine. Remember, it's just the reciprocal of cosine. So it behaves the exact same way cosine does. Now, the other four functions are all odd, and they're odd because of sine. With sine, if we plug in negative t, we're going to get the negative value of what we would have gotten if we plugged in sine t, or just regular t. Now, we know that tangent is sine over cosine, and if cosine's not changing, but sine is, it's going to change your tangent value. So all these others, because they have sine involved in their definition and of what they are, they're all odd functions. The only ones that are even are the two that are only based on cosine. So that's a good way to remember it. All right, so finding the value of a trigonometric function, regardless of whether it's a positive or a negative angle, becomes kind of easy now. We know what the values for pi over 4 are, and what do we know about the cosine function? Well, the cosine's an even function, so it doesn't matter if we put in a positive value for an angle or a negative value for an angle. It's going to be the same for a given angle. So cosine of negative pi over 4 is going to be exactly the same value as cosine pi over 4, specifically because this is an even function, and we know what the cosine of pi over 4 is. It's the square root of 2 over 2. Now tangent, on the other hand, it will equal negative tangent of pi over 4, because it's an odd function. It has a sine in it. So what happens there is, what's the tangent of pi over 4? Well, we knew that that was 1. I don't know what I'm doing with the square root of 2. And then that means we have to put the negative out front. So here's my original f of x, and since tangent's an odd function, if I take the tangent of negative x, it's just negative tangent of x. All right, you guys try these two. I'm going to give you a little bit. I'm going to pause it. You pause it, work them out, and then come back and check your answers in 3, 2, 1. All right, so with secant, we know that it's based only on cosine, so it's an odd or an even function. So the secant of negative pi over 4 is going to be the exact same value of the secant of pi over 4, which is the square root of 2. Now with our sine function, we know it's odd, so the sine of negative pi over 4 is going to be equal to the negative value of the actual sine over 4 that we learned just a second ago, which the sine of pi over 4 is the square root of 2 over 2, and since it's an odd function because we're taking the sine of the negative angle, we just throw a negative out front. Alright, now these are the first of some fundamental identities that we're going to learn. Many relationships exist among the 6 trigonometric functions. These relationships are described using trigonometric identities. Trigonometric identities are equations that are true for all real numbers for which the trigonometric expressions in the equations are defined. These are known as the reciprocal identities. We've already been dealing with these, but I want you to see them. And the sine of t is 1 over cosecant of t, that whole flipping over thing. Cosine t is 1 over secant t. Tangent t is 1 over cotangent t. These you're not going to use that much. These you will use a lot. So make sure you know these. You should know all of them because they're very simple to remember, but these are the ones that you're going to use the most. Alright, and we have 2 other relationships that follow from the definitions of the trigonometric functions, and they are called the quotient identities. Quotient, of course, because it's a division problem, and tangent t is sine t over cosine t. We've already been talking a little bit about that. That one you're going to use a lot. This one you'll use quite a bit as well, and it's just cotangent t is cosine t over sine t. Now you remember cotangent is just the reciprocal of tangent, so if we were to define tangent as sine t over cosine t and do its reciprocal, hey, guess what? We get this thing right here. Now, there are other relationships among the trigonometric functions that follow from that equation of the unit circle. Remember, we described the equation of the unit circle as x squared plus y squared equals 1. Now, because cosine t equals x and sine t equals y, we can actually go in and do some substitution and put our cosine t in for our x and our sine t in for our y, and we get that cosine t quantity squared plus sine t quantity squared equals 1. Now, we'll eliminate the parentheses by writing cosine squared t instead of cosine t quantity squared. Guys, these are the exact same things. They're just written a little different because I guess they didn't want to write parentheses. I'm not sure why. But this is written in this way so that you don't mistake it for cosine t squared. Let me write that. Cosine of t squared. If we ignored the parentheses here, if you're writing this thing instead of this, you're not really sure if the t is squared and then you take the cosine, or if you were going to take the cosine of t and then square the whole thing, but you forgot the parentheses. So anytime you see this, remember all it really is this thing right here. You take the cosine of the t, find its value, and then multiply it by itself. Alright, and we do the same thing with sine t quantity squared and write it as sine squared t. With this notation, we can write the identity as cosine squared t plus sine squared t equals 1, or if we just flip the sine and the cosine, we can because they're added and both positive. We see this, and this is the way the identity is usually going to be seen. And this is called a Pythagorean identity. And here they are. And there are others, and I'm going to show you how to get the other two. Now, this is the one that we're going to use more than anything, but we will use these as well, and you need to be able to know what they are. If you want to memorize them and learn them, you can. I don't do that. I don't remember these off the top of my head, but I know that I can find them using this. Watch this. We've got sine squared t plus cosine squared t equals 1. Now let's say that I need something that is relating secant squared. Well, I know that secant squared is 1 over cosine. So if I can divide this side by cosine squared t, I have to divide this side over here by cosine squared t as well. Now, what's going to happen here? Well, sine squared t over cosine squared t is sine over cosine all squared, and sine over cosine is tangent. I have to divide this cosine squared t into all the parts over here on the right side, on left side, sorry. And cosine squared t over cosine squared t is going to give me 1. And 1 over cosine squared t is going to give me secant squared t. So I've just derived this one. Remember, these are interchangeable. You can flip them around either way. It doesn't matter. Commutative property says it doesn't matter how we add those. All right, and we can do the same thing with this one over here. Start off with sine squared t plus cosine squared t equaling 1. And let's say I need cosecant. Well, I know I'm going to get cosecant by dividing 1 divided by sine squared t. Well, if I do it on one side of my equation, I have to do it on the other side. And when I divide that into both parts here, sine squared t over sine squared t equals 1. Cosine squared t over sine squared t. Cosine over sine is cotangent, and I'm just squaring it. And then over here, 1 over sine t is cosecant, and I'm squaring it as well because of the sine squared on the bottom. So I've now just derived this one. So if you remember this one and can do a little bit of algebra, then you can derive these two and you don't have to worry about memorizing. Alright, so let's use a Pythagorean identity here. It says, given that sine t equals 3/5 and my t value is between 0 and pi over 2, find the value of cosine t using a trigonometric identity. Alright, well, what's going to relate sine t and cosine t is my original. Sine squared t plus cosine squared t equals 1. I know sine t, so I can plug it in here and square it. I'm looking for cosine t, so I need to move that to the other side. I'm going to do the algebra first. I want cosine squared t by itself. So cosine squared t is equal to 1 minus sine squared t. And I don't want cosine squared t, I actually want cosine t. So that's where I'm going to take the square root of both sides. And the square root of cosine squared t is just going to be cosine t. And over on the other side, the square root of 1 minus sine squared t is what I'm going to calculate. Now, guys, in all honesty, remember, if we're taking the cosine, we're looking for all solutions, we got a plus or minus right here. That's where this part's going to come in, and we'll talk about that in just a second. So let's go ahead and plug our value in. So cosine t is going to equal the square root of 1 minus, now what is 3/5 squared? Well, it's 9 over 25. We square the top, square the bottom. So we've got to do some subtraction in there. Well, 1 is just 25 over 25. And I do 9 minus 25. So that's going to get me the square root of 25 minus 9, which is 16, over 25. So cosine t equals the square root of 16 over 25, which when I take that, and this is plus or minus still, I need my plus or minuses all the way through so I don't forget them. And when I take the square root of that, I'm going to get plus or minus. Square root of 16 is 4. Square root of 25 is 5. Now, that's where we look at this part right here. In quadrant 1, from 0 to pi over 2, what do we know about our x and y values? Well, they're both plus, which means that we want the plus part of our 4/5. So for that angle in quadrant 1, with a sine value of 3/5, the cosine value is going to be 4/5. Alright, here's another example. I want you guys to try this. Once again, we're still in the quadrant 1 there that we were talking about, so we know the value is going to be positive. But I want you guys to use the trigonometric identity and find what the cosine value would be. And I will show you the solution for you to check in 3, 2, 1. Alright, so here's our solution. We start off with the Pythagorean identity just the way we did the last one. We solve for our cosine, because that's what we're solving for. And then we simplify down a little bit once we plug it in. When we square sine t, we're going to have 1/2 times 1/2, which gives us 1/4. Subtract that from 4/4, and we get the square root of 3 over 4. Well, when we take the square root of that, the square root of 3 is the square root of 3, but the square root of 4 is 2, so we can go ahead and simplify the denominator. And we're looking at the plus or minus again, but we know that since we're in quadrant 1, everything's going to be positive, so cosine t is equal to the square root of 3 over 2. Alright, now this is not the end of this section. We'll probably have another video on it, but I want to stop here because I don't want to give you too much stuff, but this will get you started. And go ahead and get those notes taken, and we'll be able to do some work in class.